here for the Old Iron Lover channel, and we're here today to look at installing a knee feed or Z-axis feed, power feed on my Bridgeport mill. And full disclosure, I've had this apart and installed 2 or 3 times to see if, what the best process was, what, maybe the problems I ran into and how I got around them and all that. So rather than have an awful lot of repetitive stuff, this is kind of the final assembly. And I'll show you how I fitted some things along the way. Anyway, you can buy a servo unit for $1,000 or more. You can buy an Align or a Song. I believe they're both made in the same place in China by a pair of brothers. I think they're the A-Song brothers or A-Song brothers. They all look a lot alike. I've got an Align unit on my X-axis, and it's worked fine over the years, and it looks very, very similar to this. Anyway, this is the 150 inch-pound unit. They recommend having something that size for the knee just because of the weight you have to lift. The parts in the kit all laid out here. Basically, you're going to take off the collar and everything that goes on the dial, and the dial lock, the clutch that the handle fits into to manually run the axis up and down. You're going to take all that stuff off. You're going to take the screws out that hold the flange that holds the bearing for the shaft that runs the gear train from the crank into the mill. And we're going to put this on top of it. We're just going to reuse the screws, and it's got a couple of holes in here. Those holes go align with these, and that's how this unit mounts to the mill. The next thing is going to be installing the bevel gear. Engages this little pinion here, and there's the attendant shims that go with it. Then you get, let me rephrase that back up, you get a new shaft. That goes on in place of the, basically it screws in where the setup for the dial was. And then this goes on, the bevel gear goes on, then the dial goes back on, and they have a new ring to fit the dial. And then the clutch goes on, and you, all along you have to shim this thing. So we'll kind of talk about the shims along the way. Anyway, let's start out by taking everything off of the mill that we need to take off. Okay, we're set up over at the mill, and hopefully got enough room here to show you everything. Get your handle out of the way. The clutch in here is just a tap in and fit. It's not real tight. I think maybe my mill is a little looser than some, or a little tighter. You could put a bearing splitter in there and put a puller on it, but I believe we can just tap it out of here. Okay, we have a little wedge. My wife knows an inexpensive screwdriver. Kind of tap it down in there. There's some threads down here this runs on. It's probably just for good practice. We should not probably get into those threads. We might want to part again for something. There we go. It's coming. There we go. The first time I did this, I actually did use a bearing puller But then I realized once I got started with it that it came off so easy, I probably didn't really need it. So we got the clutch out of the way. Take the lock and the dial out. And then we got to get this off, which if it's stuck a little bit, just grab a spanner wrench. Grab a spanner wrench and smack it once, it should come right out. But it's pretty loose. My thinking is, in real practice, you should actually find it to be a little bit tight. So, and as you might expect, there's a key on the bottom. I'd really rather have it on the top here. So, I'm just going to barely stick that on, put the handle back on it, spin it around so we get to it. Get my cute little hammer, a little punch, and put the out of there. Okay, we're almost done taking parts off. We need in this case, on my machine, we need a 3/16 hex key. We'll take the 3 socket head cap screws that hold the flange in. And you move the end real quick so you can see that a little better. And all we're going to do is take these screws out. We're going to leave the flange alone. We're going to reuse those screws. Okay, when you put this thing on, just uses the same 3 screws, and you want these 2 to be above center, not off like so or like so. It'd be like this. Good and snug. Okay, now we're going to start putting new parts on. The first piece to go in is this shaft, and it screws on the threads that originally held the old adapter that the dial, the travel dial fits in. So we take that off, this goes in its place. And it should be good and snug. I don't know, I only say that because we're going to do some measuring to get the shim pack right, and we don't want this thing moving around. So anyway, that's on. We're going to mount the unit next. I'm going to go grab that. The unit sits in there like so. And now we need a 5mm wrench and a couple of screws that come with it to mount this. Hopefully you can see that down in there. Just a little bit of turning. So now that we have the power unit mounted up, the next task is to shim, and you can see there's some shims in here already, between the face of this bevel gear and the inner race on the bearing, this little needle bearing that sits inside of here, to get the proper mesh on this pinion gear. So what I did is I took all the shims out, greased into place. There we go. Took all the shims out. Meshed the gear. And then screwed this collar that's going to be ultimately the thing that pushes this into the shims. It's the clutch that the manual handle uses. Should you want to retain that, and snug that up real good. Then, as carefully as I can, I just make a measurement between the back edge of the bevel gear and the index mark up there on top. I get about 106 thousandths. Okay, now take that back off again. I did this without the key in the keyway. So I'm going to put, because I've been through this exercise a couple times playing with this, I'll put two shims in. Gear, clutch, snug it up. Okay, here we go again. Measure close as we can. The trick is keeping this thing pretty parallel to the shaft. And we're at 101 thousandths. That's probably, I'm giving myself 3 or 4 thousandths for not accurately getting the calipers in place. The shims are 12.5 thousandths, so I expect to see a big movement when I get a movement here. So, pull this off, put shim number 3 in. Bevel gear back in, clutch back in. And the roll pin holes you see there from me making bad experiments already. So, all right, again we're going to measure across here. $87. So from 101 to 87 we took off 13 thousandths, which says that shim, back up a minute, with no shims we moved in and we could have either been against the shoulder against the bearing and not needed any shims, and in fact probably need to turn some off the shoulder, or we could have been pushed against the pinion. But we put the next shim in, then we know that if the number doesn't change much, then we are up against the pinion because we're taking up the space between the shoulder and the bearing. Once we get enough shims in there that it actually spaces it out a little bit, we've taken up all this slack inside of here, then we know that we are actually pushing between here and the bearing. We're pushing out enough to take the mesh between the pinion and the bevel gear a little bit off of buried all the way in. See, and I have 3 shims here. Now I'm going to repeat this just to be double sure. So here we go with 2 shims. tightening it up until it just moves the table. Now, and I can feel that grabbing against the pinion. The pinion and it's too tight. You can feel the mesh, the teeth meshing and kind of jumping against each other. So 2 is too tight. So here's number 3. Now it's moving smoothly. It's got a little bit of growl to it in there, but I am able to at least move it. So is that enough? Well, let's find out when we measure this again. I'm getting 83. Pull shim number 3 back out for just a second. Okay, with number 2 shim, or with only 2 shims in, we go in and measure that distance. I got 106. So we can feel it growl. We got 106, which is the same we had with 1 shim and no shims. So we're right on the cusp. We must be pushing against that. It's also harder to turn it to raise and lower, which means we're binding against the gears are pushing against each other, and the teeth are binding. So the next shim we add, 12.5, should take us another 12,500. Should take us right out where we want to be. Since we don't have any thinner shims, we'll be doing 12 thousandths backlash on the gears. Now, tighten this up. Now we're able to move it fairly easily. We were at 106 up until this point with however many shims we put in there. Now we're up to number 3. We're down to 87, which is about, close to that 12.5 thickness. So we must have been real close to being at mesh, at even mesh. We were growling a little bit, but we must have been pretty close, because now we actually gained the full amount. We weren't distorting anything with the 2 shims in there. So now, just as a sanity check, let's see if it moves up and down smoothly. Seems to. Now it's going to try to unscrew itself. It seems to be beautiful. That's just perfect. So 3 shims is what we needed. What happened there is it unscrewed itself and it lost the mesh. In order to keep that from happening, the loss of mesh, is we're going to pin that, but we're going to go ahead and put the key in so the brass gear won't have a tendency to unscrew this thing. But we'll also put this in nice and snug, so we're pushing this back against the shims, or compressing the shims, all the air and the wiggle and the grease and whatever else is in there out of it. And we're consistent with the way we were measuring it before we put the key in. So next chore, pop the key in, put it back together again. And with any kind of luck, we'll have somewhere drilling another hole in it. Haven't used up all the shaft yet. And the key is right, the keyway is right there. And before I put it back together for the final time, I'm going to put a little gear lube on it. And just having done this a couple of times and seeing that whatever it doesn't need, it squeezes out into the inside there, or into the inside of the housing here. So it probably doesn't matter if I get a little bit too much. Okay. Oh, great. Put the key in and had a shim stuck to it. There we go. Guess it's time to wipe my hands off. Alrighty, now we got the key in. Feels like we're meshed. And we're going to put the dial back in, and last several times I tried it, it took 4 shims to get it spaced out so the dial leaves just enough daylight in there that you can see in there, and that's about it. And we put the lock collar for the dial in. And when we cinch it up, we still have just a hair of daylight in there, which is, I think, just about what we want. Now the next thing is to put this back on in about the same condition as we had it before as far as tightness goes. Like that. And they want us to drill this. Okay, well, off camera I went ahead and put the roll pin in. We're going to test it one more time, make sure everything looks like it's working right. Okay, it seems to be working fairly well. I'm a little bit worried that it's going to be underpowered. It feels like it's straining a little bit to lift the table. Just as an aside, before I did this last iteration of putting this all together, I checked the lubrication and the gib fit and everything on the knee gibs and the knee dovetails. It wasn't, the one shot wasn't lubricating very well, so I hand lubricated it. And then, ran it up and down by hand, make sure it felt good that way. So I think that's as good as we're going to get it. There's always one size bigger, or 2 sizes bigger, I guess, if I have to go that way, but we'll see how it works. Anyway, next step is going to be to mount the limit switch and the stops, and put the optional, in my mind, spring-loaded handle on it for the manual operation. I'm not real crazy about having my handle out here. I think that's a lot of real estate that I'm going to run into if nothing else. So probably won't do that. There's a spring, push the handle on, and there's a little retainer washer and a screw in the end of this that holds it all together. Don't see any real reason to put that on. So anyway, I'll shut down for a minute and go gather up everything for the limit switch setup. So as far as putting the limit switch on, the book talks about using it in the longitudinal or the x-axis mode, and makes no mention of mounting it on the knee. But it should be pretty straightforward. We're going to mount the limit switch on the actual knee, and then we're going to mount the limit stops on the column like so. Okay, a little bit of traveling up and down and trying things. Decided to mount this little sheet metal bracket they give you for the stops right in here. It's just on the column, just behind where the knee weights are. And put the original block up here, and the original block set it out right about like that. And so the point of that was right about the edge of this, so I took half the diameter of the little spring-loaded doodad here, milled it off the back of the block that it mounts on, and it should be pretty close now. Let's check it out. Yeah, that's going to be beautiful. Bottom line is, kind of got this hand fitted in here. It's going to sit right in here. I've put a mark on there for the first hole. Going to drill it for a quarter 20 hole. And not going to be very deep, because I just hate to think about running into something I didn't want to run into. So I'm going to take it in about 3/8 of an inch or so. Something that's pretty much a given. Well, I believe we should have plenty of room for this set. Go straight right there. Punch out of the hole. A little bit.
problem with that. Okay, tap the other hole and we'll mount this thing up. And since we can, let's just go ahead and run the bottoming tap in and finish it up. Okie dokie. Mount that up. Okay, those are mounted. Get down here where I can see what I'm doing. Okay, let's see what happens. We're going to hold there for just a second. That's about as far as I want it to go. Okay, let's tighten everything down right where it is there. Okay, we need to tighten that up. We're going to crank this all the way up to the top and set the upper limit, and we're good to go.
Oh, it's right there. Well, that wraps it up. Overall, I'd say the ASONG unit is serviceable. It doesn't work as well as I would like on this mill. The knee is a little stiff, and I have not, even manually and adjusting the gibs and everything else is still pretty stiff. This is kind of underpowered. It will trip out if I get up onto the less worn areas of the knee dovetails. As far as pricing goes, this is about $350 or $60, something like that. And if you really want to go, you know, for the Cadillac, you get yourself a servo, but you're looking at, I don't know, $1,100 or so for that, and that's $100 less than I spent on the mill to begin with. So the instructions leave a lot to be desired. What you didn't see in the video, and it's just too much repetition, there's a lot of trial and error to figure out what works and what doesn't work, and fill in the blanks where there, you know, suggestions could have been useful. I think if somebody were doing this as a beginning type project, you would struggle with it. I mean, I've already put one of the ASONG brothers feeds on the x-axis, and so I've done a little bit, and I played around a lot with this, and it was a struggle in places, but in the end it worked out fine. So stay tuned for other videos, and thank you for watching.